In this video, we're going to be solving a radical equation of the form a times the square root of f of x is equal to g of x. In number 1, it wants us to write each equation in the form of a times the square root of f of x is equal to g of x, and then it says to isolate the radical term on one side of the equation. So in a, we have 2 times the square root of x plus 1 minus 3 is equal to x plus 7. So the first thing I'm going to do is distribute the 2 through the parentheses. So I'm going to have 2 times the square root of x plus 1 minus 6 is equal to x plus 7. And now I'm going to add 6 to both sides. So I have 2 times the square root of x plus 1 is equal to x plus 13. In b, we have x minus 2 times the square root of x is equal to 4. So the first thing I'm going to do is subtract x from both sides. So we have negative 2 times the square root of x is equal to 4 minus x. And now we're in the form of a times the square root of f of x is equal to g of x. And they give us some rules on solving a radical equation of the form a times the square root of f of x is equal to g of x. And we'll see these steps in the examples to come. For 2, it says find the real solutions of the following equations. A, we have the square root of 5x plus 1 plus 2 is equal to x plus 3. So the first thing it wants us to do is isolate the radical term. So we have the square root of 5x plus 1 is equal to, and then we're going to subtract 2 from both sides. So we have x plus 1. And now it wants us to square both sides. So we have the square root of 5x plus 1 squared is equal to x plus 1 squared. And this was one of our perfect square trinomials. So a plus b squared is equal to a squared, so x squared, plus 2ab, 2 times x, plus b squared is equal to 1. And on the left side of the equal sign, we have the square root of 5x plus 1 squared, leaves us with 5x plus 1. And now we're going to move all the terms from the left to the right side of the equal sign so that we have a positive x squared term. So I'm going to have x squared, and now we have 2x minus 5x is minus 3x. And then we're going to have 1 minus 1, which is 0, is equal to 0. And now I'm going to write this in linear factors. So I have x times x minus 3 is equal to 0. So our possible solutions are x is equal to 0 and x is equal to 3. And we want to check to see if 0 or 3 is an extraneous solution and then write the solution set. So we're going to plug 0 and 3 back into our original equations. So for x is equal to 0, we have the square root of 5 times 0 plus 1 plus 2 is equal to 0 plus 3. And we have 5 times 0 is 0, and the square root of 1 is 1. So we have 1 plus 2 is equal to 0 plus 3, which is 3. And 1 plus 2 does equal 3, so this is true. So x is equal to 0 as part of our solution set. And for x is equal to 3, we have the square root of 5 times 3 plus 1 plus 2 is equal to 3 plus 3. And now we have the square root of, we have 15 plus 1 is 16, plus 2 is equal to 3 plus 3 is 6. The square root of 16 is equal to 4, and 4 plus 2 does equal to 6. So this is also true. So our solution set is 0 and 3. For b, we have negative 4 plus the square root of x squared plus 5x minus 8 is equal to x. And they want us to isolate the radical term. So we're going to do this by adding 4 to both sides. So we have the square root of x squared plus 5x minus 8 is equal to x plus 4. And now they want us to square both sides. So we have the square root of x squared plus 5x minus 8 squared is equal to x plus 4 squared. And now the square root of x squared plus 5x minus 8 squared is x squared plus 5x minus 8. And then we have another perfect square trinomial, so we're going to have a squared, which is x squared, plus 2ab, which is 2 times 4 is 8x, plus 16, b squared. And now when we subtract x squared from both sides, they will cancel out. And then we're going to have minus 8x from both sides would give me negative 3x is equal to, and then if we add 8 to both sides, we get 24. And x is equal to negative 8. And then we want to check to see if negative 8 is an extraneous solution. So we have negative 4 plus the square root of negative 8 squared plus 5 times negative 8 minus 8 is equal to negative 8. And then we have negative 4 plus the square root, and we have negative 8 squared is 64. 5 times negative 8 is negative 40. And then we have minus 8 is equal to negative 8. And now we have 64 minus 40 is 24. Minus 8 is 16. So we have negative 4 plus the square root of 16 is equal to negative 8. And the square root of 16 is equal to 4. So we have negative 4 plus 4 is equal to negative 8. And that is false. So we have no solutions for this equation. So our solution set is empty. In C, we have 3 minus x divided by the square root of 6 minus x equals 2. And they want us to isolate the radical term. So if we were to cross multiply and think of 2 as 2 over 1, we could say that we have 3 minus x times 1 is equal to 2 times the square root of 6 minus x. And from here, we're going to square both sides. So we're going to have 3 minus x squared is equal to 2 times the square root of 6 minus x, all squared. And when we square the left side, this is one of our perfect square trinomials. So we have 9 minus 6x plus x squared is equal to 2 squared is 4, and the square root of 6 minus x squared is 6 minus x. And now I'm going to multiply 4 through the parentheses on the right side. So 4 times 6 is 24, and then 4 times negative x is negative 4x. And now we'll move everything to the left side of the equation where x squared is positive. So we have x squared, and then we have negative 6x plus 4x is equal to negative 2x. And then we have 9 minus 24, which is equal to negative 15, is equal to 0. And now we're going to write this in linear factors. So we have x minus 5 times x plus 3 is equal to 0. So our possible solutions are x is equal to 5 and x is equal to negative 3. And now we want to see if 5 and negative 3 are extraneous solutions and write our solution set. So we have when x is equal to 5, we have 3 minus 5 divided by the square root of 6 minus 5 is equal to 2. And then we have 3 minus 5 is negative 2 divided by 6 minus 5 is 1. The square root of 1 is 1. So negative 2 is not equal to 2. So this is false. So 5 is an extraneous solution and not part of our solution set. And when we check x is equal to negative 3, we have 3 minus a negative 3 divided by the square root of 6 minus a negative 3 is equal to 2. And now we have 3 minus a negative 3 is equal to 6. And 6 minus a negative 3 is 9, and the square root of 9 is 3. And 6 divided by 3 does equal 2, so this is true. So our solution set is negative 3. In D, we have 2 times x minus 3 to the 1/2 plus 4 is equal to x plus 1. It wants us to rewrite the exponential term as a radical. So we have 2 times the square root of x minus 3 plus 4 is equal to x plus 1. And now we're going to subtract 4 from both sides. So we have 2 times the square root of x minus 3 is equal to x minus 3. And now we're going to square both sides. 2 times the square root of x minus 3, all squared, is equal to x minus 3 squared. And 2 squared is 4. The square root of x minus 3 squared is x minus 3 is equal to, now we have a perfect square trinomial, so we have x squared minus 6x plus 9. And now I'm going to distribute the 4 through the parentheses, so I have 4x minus 12 is equal to x squared minus 6x plus 9. And I'm going to move everything to one side of the equation, so I'm going to subtract 4x and add 12 to both sides. So we get x squared minus 10x plus 21 is equal to 0. And then write this in linear factors, so we have x minus 7 and x minus 3 equals 0. So our possible solutions are x is equal to 7 and x is equal to 3. And now we want to check them to make sure they're not extraneous solutions and write a solution set. So when x is equal to 7, we have 2 times 7 minus 3 to the 1/2 plus 4 is equal to 7 plus 1. And then we have 2 times 7 minus 3 is 4. And the 4 to the 1/2 is equal to 2. So 2 times 2 plus 4 is equal to 7 plus 1 is 8. So we have 2 times 2 is 4. And 4 plus 4 does equal 8. So this is true. And if we want to check x is equal to 3, we have 2 times 3 minus 3 to the 1/2 plus 4 is equal to 3 plus 1. And we have 3 minus 3 is 0. 0 to the 1/2 is 0. And anything times 0 is 0. So we have 0 plus 4 is equal to 4. And this is true. So x is equal to 3 is also part of the solution set. So our solution set is 3 and 7. And that's our video on solving a radical equation of the form a times the square root of f of x is equal to g of x.